Hello, this time Decibels Level 2. First question. Right, in Level 2 we have two gain blocks, and the gain blocks can be labelled either in power gain, voltage gain, or just gain in dBs. And it's important to understand the difference. The gain in dBs would be 20 times the log 10 of the voltage gain. The power gain is the square of the voltage gain, and the voltage gain is just the voltage gain. So here we have an input which is 0.4 volts. It's going through a block with a gain of 13 dBs, then a block with an unknown gain, and the output is 124 millivolts. Right, let's have a think about that. 0.4 volts, if it goes through a gain of 13 dBs, then in voltage terms, well, the formula for gain in dB would be 13 equals 20 log 10 V out over V in, and V out over V in is the voltage gain. So here we would have a voltage gain, I'll write that as GV, equals 10 to the power of 13 over 20. And I get that just from noting that GV is V out over V in by definition, and then taking this equation, dividing both sides by 20, and then taking 10 to the power of both sides. If that is the voltage gain of this block, then the input voltage at this side here must be 0.4 times 10 to the power of 13 over 20. And the output here is 124 millivolts. So I can work out the voltage gain of this block here. That's just its output divided by its input. So the gain of the unknown voltage, that's this one, must be 124 millivolts, that's the output, I'll write it as 0.124, divided by the input, which is 0.4 times 10 to the power of 13 over 20. And that will give me the voltage gain. But remember the power gain, I'll write it as GP, that is the voltage gain squared. Since the power is proportional to the square of the voltage, the voltage gain, which will be V out over V in, if I square that, I will get something that must be equal to P out over P in. And that's the power gain. So my answer must be this expression here, all squared. Let's try that. So, open bracket, 0.124 divided by, open bracket, 0.4 times 10 to the power of 13 over 20, all squared. Great. Next. This is a similar one. This time the output voltage is unknown, but we're told the input and the gain of the two stages. We're just told the first as a power gain and the second as a gain in dB. Right, well, first thing to do is to work out the output voltage there. And we can get that from taking the input, 0.2, multiplying by the voltage gain of the first stage. Well, if the power gain is 0.0468 and the voltage gain is the square root of the power gain, then that stage in terms of voltage terms would just be 0.0468 square rooted, and SQRT is how you work out the square root in this calculator. And then I'd multiply that by this block, which has a gain of 23 dB, so in voltage terms that would be a gain of 10 to the power of 23 divided by 20, and that is my total output voltage there. However, we're not asked for the output voltage in volts, we're asked for the output voltage in dBV. And dBV is a way of expressing voltage amplitudes in decibel terms. dBV is calculated by taking 20 log 10 of the actual output voltage, or input voltage, in this case it's output, divided by 1 volt. You could only take the log of something which has no units, so you can't take the log of a voltage really, you have to take the log of a voltage ratio. And I can get a voltage ratio by dividing the voltage by a reference voltage, in this case 1 volt. Here I have an output of, what was it? 0.61115 or so volts. So if I divide that by my reference voltage of 1 and take the log to the base 10 and multiply by 20, that should give me my output in dBV. Right, let's try that. 20 log, I could just write x. It's the number in the x box down here. Great. Next one. Right, that's a more interesting one. Unknown input voltage in volts peak to peak. Aha, right. Here we have the output voltage, which is specified as 2.43 millivolts. We have a voltage gain here, and a gain in dBs there, so we should be able to work out what the input voltage here in terms of RMS voltage quite readily. If the total gain of our system is, let's see, minus 23.5, in terms of voltage gain, that would correspond to 10 to the power of minus 23.5 divided by 20. And this has a voltage gain of 0.0519, so 0.0519, that's the product of these two voltage gains. The total voltage gain of our two-stage amplifier here is 0.0034687. Right, Vout is Vin times the gain. Therefore, Vin is Vout divided by the gain. And we know Vout, 2.43 millivolts. We've just worked out the gain, 0.003467. So we can work out the voltage input just by doing that division. 2.43 milli divided by 0.003467, 0.7, approximately 0.7. Right. So the RMS voltage here would be 0.7, but that's not what we're asked for. We're asked for the input voltage in peak to peak. And at this stage, it's very helpful to know the relationship between RMS and peak to peak. In particular, that the RMS voltage is the 0 to peak voltage divided by the square root of 2, which is the peak to peak voltage divided by 2 times the square root of 2. So I would have to take my answer here, my 0.7, multiply it by 2 root 2 to get the peak to peak, and then I get my right answer. Okay, I think that should get you started.